So our task is to define oxidation. What is oxidation? Well, on the most basic level, oxidation just means to react something with oxygen, to add oxygen to something or react it with oxygen. Where's oxygen on the periodic table? Here's oxygen. Okay? And you will see that what oxidation really is it concerns the movement of electrons. But on the first level, on the surface level, it's really just the combination of something with oxygen or the reaction of some chemical with oxygen. Let's look at a very simple example. Let's take a metal, something on this left side of the periodic table. Let's say magnesium. Let's take magnesium. Now let's use a black color. Oop. Sometimes the color picker is annoying. So we take a black color and we react magnesium with oxygen. And I'm going to make oxygen diatomic. It's an oxygen molecule, O2. And what are we going to get? Well, if you react magnesium and oxygen, it doesn't take a genius to realize you're going to get magnesium oxide. These two things are going to stick together. And to make sure it's balanced, if we have two oxygens on this side, then we need to balance here. So we balance with big numbers, B for B. And now we have two magnesiums there. We can add two magnesiums on this side, so 2Mg. Okay, that's the reaction. And what this reaction is it's an oxidation reaction. Well, technically it's a redox reaction, but for now let's just call it oxidation. So who have we oxidized? We have oxidized magnesium. Mg has been oxidized. Make sense? We took magnesium, we combined it with oxygen, we oxidized magnesium. In a second, I'll talk about what the opposite of that is, which is reduction. But for now, let's just think about oxidation. So now we've defined oxidation in one sense as oxidation is the gain of oxygen. Gain of oxygen. Or you could also think of it as reaction with oxygen. Reaction, I'm writing as RXN, with oxygen. So that's one definition. But we can go a little bit deeper. We can think about what is actually happening with the electrons. Because as you know, all of chemistry, or most of chemistry, is really about the exchange of electrons. So let's take a look at what these atoms are on the periodic table. Magnesium is in group 2, we know. So magnesium is in group 2, and it has 2 outer shell electrons. And oxygen is in group 6. It has 6 outer shell electrons. So let's draw a simplified version of those atoms down here. Let's do that. Let's write Mg with its 6 electrons, So 1, 2, 3, 4, 5, 6. And then we will write O with its, Mg with its 2 electrons. O with its 6 electrons. 1, 2, 3, 4, 5, 6. Okay, now how can these two react? How can they react? Well, one option is they could share their electrons, a covalent bond, but it doesn't quite. Oxygen isn't interested in that. Oxygen is a pretty greedy atom. That's how you can think about it. Oxygen is pretty greedy. It wants electrons for itself. So what's oxygen going to do in this case? In this case, oxygen is just going to steal those electrons. It's just going to say bye-bye. Bye-bye, electrons. Thank you very much. And it's going to put them in its shell. So now oxygen is very happy. Why? Because it has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And magnesium has lost 2 electrons, but it's not quite unhappy because remember, magnesium has 2 in the outer shell. So if it loses that outer shell, the next shell down is complete. The next shell down is what neon looks like. And the goal of all atoms is to become like the noble gases. That's why they're called noble gases, because they're kings and queens, and everyone wants to be a king or a queen. Okay? So magnesium, even though it's lost 2 electrons, it's kind of happy. But now notice what is going to happen to the charges. Here we gained 2 negative things. We got 2 negative vibes, and so our total charge is going to be 2 negative. Let's put that in black, 2 negative. And here the total charge is going to be 2 positive. Now what happens to negatively charged and positively charged things? Well, they They stick together. They stick together. And so what's going to happen here then is that, no, Siri. What's going to happen here, let's do that again, is that, oh, what is going on? Is that magnesium and oxygen are going to come and stick together. So now we have the MgO molecule that we saw here, MgO. But of course, remember that since we have O2, O2 is diatomic, oxygen is diatomic. So if we have one O and another O, usually they're bonded together like this. So 1, 2, 3, 4, 5. Now let's draw that over here. 5, 6, and then 1, 2, 3, 4, 5, 6. What oxygen is going to do is they're going to basically share this bond over here. So this is going to become a bond. They're going to share these two electrons, so that now each oxygen basically has 8, right? 1, 2, 3, 4, 5, 6, 7, 8, and that one has 8. And so in order to react with magnesium, they're going to have to break apart. They're going to have to break apart. And let's break them apart. So that one breaks apart, okay? And it reacts with the magnesium by stealing its electrons and then becoming an MgO. And this one as well will break apart, react with the magnesium, become an MgO. And so in the end, we should have how many MgOs? 2 MgOs. 2 MgOs. And voila, that is why up here we have 2 MgOs. So we had one oxygen molecule broke apart, and each of those oxygens stole electrons from magnesium to make its full outer shell, and that gave us a 2 negative charge, and those then bonded with the 2 positive charged magnesium. Okay, what's the point of all this fun stuff, of all this jargon? What I'm trying to explain here is simply the following fact, that even though while the first definition of oxidation is a gain of oxygen, the real definition underneath the movement of the atoms, what's really happening is that during oxidation, the oxygen has stolen electrons from magnesium. So oxygen took those 2 electrons from this magnesium. And so you can also define oxidation as the loss of electrons. When something gets oxidized, it will lose electrons. It'll bond or react with oxygen. But why is oxygen there in the first place? To steal your electrons. So be careful, because when you react or you gain oxygen, you're really losing electrons. So oxidation is the gain of oxygen or the loss of electrons. So that's the second definition. The third definition concerns hydrogen, and I will do that in a separate video.